Alright, unfortunately Screencast lost my original cast of this one, but I want to talk through kind of the solution that I did. So what you're going to notice is on this first one it says let f be the function given by f of x. The third degree polynomial for f about x equals 2 is given by which of the following. Alright, so first thing I did is I went down this side and I took our derivatives. So I found f, f1, f2, f3, each of the derivatives going through. It was interesting to note like the sign change as we went through. We take the derivative of ln, it gives us a 1 over x structure, but then we have a minus x in there, so chain rule gives us a negative. Then we end up on the next step, we multiply by a negative exponent, we lower the exponent by 1, and then chain rule we multiply by another negative 1. That's how each of these terms stays negative as we go through. Once we have each of the derivatives using chain rule, then we're going to plug in 2. When I do that, I get 0, negative 1. So 0, negative 1, negative 1, and negative 2 as you see here. Alright, from that point we really just go straight to our structure that we have for a Taylor. And we know it's going to be x minus 2 because they told us the center. And then we just drop in each of our derivative values over the corresponding blank factorial. So whatever degree the term is, if it's a first degree term, it's 1 factorial. Third degree term is 3 factorial. Clean this one up a little bit. We get that line down here at the bottom, which matches up perfectly with choice B. Alright, so again, this one was all about taking the derivatives. Really good example. That's kind of the brute force method of just finding a Taylor polynomial from scratch. The other one that was a common most missed problem was example 3. It says, what's the coefficient on the x squared term? Alright, so when we're looking at an x squared term, we're really looking at this structure for the term. Alright, so we need to find, alright, when we look at this one, we need to find this piece here because that corresponds to our coefficient. So I have to find the second derivative at 0 and then divide that by 2 factorial or divide it by 2. So when I go into taking the derivative, the first derivative, right now I'm going to think of that as 1 plus x to the negative 2. So the first derivative, negative 2 out front, lower the exponent. That would give me negative 2 times 1 plus x to the negative 3. All right, there's no chain rule involvement because the derivative of the inside is 1. So now we repeat the derivative process. So negative 3 times negative 2 is 6. All right, 6 times x plus 1, or sorry, 1 plus x, raised to the negative 4th. All right, so we end up with that for the second derivative. I plug 0 in, and that gives me 6. Alright, so now I need to take that 6, and I want to think of it in terms of this structure. So I've got 6 for the second derivative over 2 factorial, which is 2, times x squared. That's a 3x squared, so the coefficient is d. Alright, so that's the two problems that were most missed on this one. And I hope that helped. Bring your questions on Tuesday.